Something different today. I'm going to share a few ideas and keen to know what people think. This is not going to be about the Twin Otter, although that project will continue, and I hope to post videos about the Twin Otter cockpit from time to time. But I've been flying the Twin Otter cockpit around for 2 or 3 months now, and what's become quite apparent is, out of all these very nice panels that I've made, by far and away the ones that get the most use are the Autopilot and the GPS panels. And that's not just with the Twin Otter, by the way. I've used these panels very successfully flying other aircraft around, notably the Relair Scout, which is probably the aircraft I use most other than the Twin Otter in FSX, but also other things like the BN2 Islander from Flight 1, and I've been experimenting with the Learjet. I'm thinking of buying the Lionheart L24 Learjet as well, and all those things can be very successfully driven from the panels that I've made for the Autopilot and the GPS, with a bit of remapping obviously of the software. And I was thinking back to, when I was doing my blog during the building of the cockpit, I was talking about the idea of doing some tutorials to help people build their own versions of these panels or similar ones. And so in that vein, I've gone ahead and designed a couple of new panels, and these are the prototypes. This is one of them. This is, hopefully you can see this well on the video, this is a different version of the GPS panel. Now obviously it's input only, there's no screen on this, and I've designed it essentially with the GNS 530, Garmin GNS 530 in mind. And I've done that not because everyone will have the GNS 530, but it means that it's a superset of the built-in G500 GPS. And the plan is really that if you have a panel with all the features of this one on, then you can drive any GPS product. So this is going to work fine with the GNS 530 from Reality XP, which is the one that I've got running at the moment on my Twin Otter. It will work with the GNS 530, a kind of faked version that's built into the Twin Otter, whether you're using the 2D panel or the 3D virtual cockpit version. It's got basically everything that, if you've watched my Twin Otter videos, it's got everything that the Twin Otter cockpit has in it, but it's got 3 extra things on here. We've got the Rotary Controls, and I've marked them up on this graphic at the moment, and this is kind of a work in progress, as if they're going to control the ADF radio, the VOR2 OBS, and the gyro heading indicator adjustment. But actually, when it comes to the programming of these things, they can be anything. And the reason I put those on, they're obviously nothing to do with the GPS, but in building an authentic panel and allowing you to fly your aircraft more realistically, you really want these rotary controls to be there at your fingertips. You don't want to have to using the mouse and so on to control those. So now the reason I've chosen those particular 3 rotary controls for this will become apparent when I show you my other panel, which I'll do now, because this is the Autopilot panel. Again, I've added, I'll come back to what's on the Autopilot panel in a second, but these at the bottom, these are 3 more rotary controls, and on this panel I've chosen to implement them as the Nav1 OBS and heading bug, and also the Colesman adjustment. So it says baro on this, it's a barometric pressure. So basically that's the reason I've put the OBS2 and the ADF, so there's the lesser used, if you like, rotary controls on the GPS panel. So if you had both of these panels, you've got a full complement of rotary knobs to allow you to fly and navigate pretty much hands off. So that's the idea. What I've tried to do is put on here all the controls you're going to need to pretty much drive any regular autopilot. So we've got heading hold, nav hold, we've got approach, back course, We've got altitude hold, IAS hold, you don't always get that. We've got an altitude alert, rotary control for setting the altitude. So the button says arm here. On this, if you map this onto the Twin Otter, the button doesn't say arm, but it's the same function as the altitude alert autopilot function. We've got vertical speed mode, and we've got up and down adjustment for the altitude hold mode and vertical speed mode, and so on. And so that is going to allow you to fly, certainly the Twin Otter, giving you almost all the functions of the Twin Otter autopilot. It will implement fully the Bendix King KFC 225, I think it is, which is a superset of the one that's implemented in the default FSX aircraft. So if you look in the Cessna 172, that's the one with, not with the G1000 system, but with the old-fashioned autopilot and stuff. That's the autopilot in there. I think it's actually it's not in the Maul. The Maul's got a simpler autopilot, but again, the Maul can be flown with all these a subset of these buttons. The Mooney, same thing. So the idea is you can pretty much, depending on the programming you set up, fly any aircraft and operate the autopilot hands off and without a mouse. Not hands off, without a mouse is what I mean. What else have I got on here? Well, as I said, we've got the 3 rotary controls which you can map to anything you want, but it makes sense on the autopilot panel to have the Nav1, OBS and heading bugs on there. We've got a few extra functions on here as well. These can, if you were to build a panel like this, you can map these to anything you want really. But I've put an extra rotary control on here, which I've put in for the seat position adjust. If you can see the Twin Otter in the background there, I have that on the Twin Otter, and that's a very handy function, so that's why I've included that. Again, you don't have to use it for that function, but it's there. And finally on here we've got the Autopilot Master. I've chosen to implement the Autopilot Master as a push button. Now on the Twin Otter it's a toggle switch, and I like that better. It's more authentic for the Twin Otter, and it looks nice, and also it tells you by looking at the panel that the autopilot's engaged or disengaged. The problem is it's not implemented as a toggle switch in other aircraft, such as, if you're using the Bendix King, for example, it's a push switch, and that is significant because using that Bendix King autopilot, if you select, for example, heading mode, that not only engages heading mode, but it turns the Autopilot Master switch on as well. Now that's different to how it works in the Twin Otter, and if you had a toggle switch there, it means as soon as you do that you're out of sync. So it makes more sense to, and makes this more generic if we use a push button for that. The other 2 controls I've got here, just 2 buttons for my track IR. I've got, again on my Twin Otter panel, I've got a pause button up here, and I've got a centre button here, and I use those a lot, so makes sense to have them on the panel. Incidentally, you notice this is a different colour. This is I was just experimenting with different colour graphics. Really, this is closer to the actual Twin Otter panels in the virtual cockpit. Sort of grey with white lettering. Also, my black cartridge was running out, so it was quite fortunate. So there you go. I've built these 2 panels. Now, why have I done that? Well, I've been thinking really about what's involved in building a panel like this. These are prototypes. I made these entirely by hand, and they look pretty good. They're not bad. If you were to look very closely, the edges are a little bit rough, and really the most difficult part of building a panel like this is basically cutting and drilling these acrylic sheets, and I think that's what's going to put people off. That's what's going to defeat people, and it's hard. It's difficult. It's not straightforward, and it's very error prone. It takes a lot of time, and the results are still fairly, handmade. So what I've decided to do is I'm playing around with the idea of producing some sort of kit to build these panels, and the most important part of that kit is going to include the acrylic panels pre-made. And don't forget that in terms of how to mount these, you may or may not be able to see these. On the back of the panel, some of these components are sitting in sort of recesses, and what I mean by that is the holes on the rear of these two acrylic sheets are larger than the holes on the front side. Because the components are very shallow, the threaded insert that you use to mount it on the panel is actually very short. So what's going to happen is, let's imagine we produce a kit to make this panel. It's going to come with, at a minimum, 2 acrylic sheets cut to the right size with all the holes that you need, and that includes those recessed holes on the back side. And they're not going to be drilled, they're not going to be hand cut, they're going to be professionally laser cut, so they're going to be beautifully done with nice radiuses on the edges. All the holes are going to be perfectly finished with no flaws, there'll be no cracks, no scratches hopefully. Basically ready to mount the components on. And the other advantage of that is you can create your own graphics. If you were to want to build one of these panels and you get the 2 acrylic sheets, what I'm intending to do is to supply obviously the graphics in Photoshop format with all the layers and things you need, or in other formats that people are going to be able to use. But you can edit it as well. You can change the colours, you can change the captions if you want to map these to different buttons. You might want, again, the GPS is very generic. I've marked it up as a Garmin GNS530 here. You don't have to do that. It just makes some kind of sense, and it just looks kind of nice to do that. And as I said, that's fairly generic. But if you were to build this panel, the Autopilot, you've got some choices to make really. You could keep this as generic as possible, in the knowledge that you're going to use it with lots of different aircraft and chop and change between them. Or you could decide that you want to build something specific, whatever it is that's your aircraft of choice, Twin Otter. You can change the captions on these, and also, crucially, you can change the actual functions that you map to these. You might not have a track IR, a lot of people do, but obviously it doesn't make sense to have 2 track IR buttons if you don't have a track IR. So you can create your own graphics. What you can't do really is create different graphics and then swap them in and out, because to do that requires dismantling the panel, which once it's soldered up, that's really not something that's changeable. I'll say one more thing about the GPS, which is interesting. You might not have noticed it, but if you're sharp, you will have noticed it. As I say, it's the GNS530. It has all the functions that the Twin Otter has. But you might notice, if you've got a keen eye, that these are not dual concentric controls on the outside here. They are rotary controls, but they're the single rotary controls with a push switch incorporated. And the reason I've done that is, I'm going to talk about costs in a little while. Even if you buy this as a kit and you build it yourself, it's not going to be cheap. And those dual rotary controls, including the knobs, are £20 each, and so they significantly add to the cost. And you don't really need them, because with the right programming you can use these single rotary controls. I don't know, if you're familiar with how this GPS operates, typically the outer knob of the concentric pair switches the group, and the inner knob switches the page within that group. So for example, if you wanted to go to the nearest waypoint screen, you'd turn the outer knob a couple of times, and then you'd turn the inner knob to move between nearest airfield, NDB, user waypoint, and so on. Same functionality on here. You push and turn to navigate between the groups, and then you just turn to navigate between the pages within the group. And I've tried that out on my existing panel. That works very intuitively, works very smoothly, and the only thing that you're missing, the slight inelegance that creeps in, you lose that centre push function, for which I've put a separate push switch next to it, and that's positioned so that if you're using this right-handed, you can just hit it with your thumb. If you're using it left-handed, same thing, but you'd have to use a finger. And again, that works pretty well. Just in terms of the GNS 530, that push function is used on the left hand knob for toggling between the nav and com radios. That switch is a bit sticky. On the right hand side, it's the cursor button, so it selects or deselects the cursor. And that keeps the costs down. Now, if you want it completely authentic, there's no reason why you can't substitute those with the actual dual concentric controls. I say there's no reason. The different sizes, the insert is smaller on the dual concentric, oddly enough, which means the hole's too big for it really, but actually by using a different size nut, possibly a washer, but probably not. There's probably not room for a washer, but using a slightly bigger nut, there should be no problem with that. It just costs you an extra like £25 or something like that. So the plan is, you know, I've done some numbers on this and I've done some thinking. Well, there's going to be two kits, basically two kits. You know, you can build either of these panels, or you can build both. But you know, again, according to budget, I've designed each of these panels in such a way that the Autopilot requires one Leo Bodner BBI32 board, and the GPS panel requires one additional BBI32. In each of those boards can control 32 switches, and I've designed these so that each comfortably fits within that, but actually you have a few switches left over, or a few inputs on the Bodner board. So you can use those for other things if you want. So there's a number of different options for what you might get in a kit to build one of these panels. I mean, the simplest option is to offer, you know, a sort of entry-level kit, which is basically just the two acrylic sheets. Well, and also you probably get a DVD or a CD-ROM with the templates for the graphics on for you to tinker with and then print out yourself. But also there'll be a detailed manual about the construction of this, so how to mount the components, what to do, you know, what needs to be soldered, how to connect them up to the controller board, but also not just about the hardware assembly, but crucially the programming as well. Now the programming is going to be based on Linda, which is free, but Linda requires that you have a fully registered or a registered version of FSU IPC. So you know, you can't do this without that. And I won't go into the reasons for that, but particularly the functionality I've described about the for these rotary controls, the push and turn. You can't do that without FSU IPC, as far as I know. So and obviously you need to buy a Bodner board as well. I mean, you could buy a different kind of controller board if you wanted. I don't know why you would. The Bodner boards are pretty much the most reputable ones available. The modern APIs in Windows do allow 64 inputs on a joystick controller board, and the Bodner boards only implement 32. But FSU IPC doesn't support the modern APIs, so again you probably won't see any advantage from buying a different, you know, a board that can accept 64 inputs. Then you know, you're free to source the components either from the component list that I supply, or alternative versions of the same thing. Again, you know, I wouldn't recommend you using different components without doing some very careful research, because you need to make sure they're going to fit in the holes, the mounting thicknesses are all correct, and so on. And these are great components. I've selected these because they look good, they work well, they're industrial grade. But you might want to go cheaper, you know, that's going to be important to some people. I suppose a stage 2 kit would be, you know, that I've just outlined, but a component pack as well. So you could buy a pack with all the components in, and that just makes it easier for you. If you're going to use the same components, you can buy them all in one go without having to source them separately. And you'd be paying a slight premium for that, but in the grand scheme of things, it's not going to be a huge premium. Next up, you know, we could the stage 3 kit might include everything you need, so including the body and board as well as the components. Now the difficulty with that is there's two different versions of the body and board, again according to costs and how, you know, confident you feel. The simplest option is to buy the £30 board which has the push fit connectors on it, and that's absolutely easy to use. Anybody can do that. You can tear it down later to use the board for some other purpose, or to, you know, for whatever reason you want. But there is a cheaper version, significantly cheaper version, and the only difference is it doesn't have those push fit connectors. You have to solder onto terminals on the board. They're easy, you know, the soldering is not difficult at all. They're large, fairly large pads. So leaving that as an option again allows you to keep the costs down. If I do offer an all-in inclusive kit, I think it will be using the push fit body and boards. I don't like the idea of offering a kit that has somebody else's equipment in it where there's any significant chance of it going wrong. You know, the last thing I want is to sell a few of these and then have people bugger them up when they're trying to solder onto them and then send them back to me as faulty. It's just messy. So I want to know what people think. You know, would you be interested in buying a kit along any of the lines I've just outlined, really, for building a GPS panel like this? Input only, so you can use it to drive the 3D virtual cockpit GPS. You can use it to drive the 2D panel. You can put the 2D panel on an external monitor if you want. But that's independent of this. Would you be interested in buying that in kit form to use with any and all of your aircraft? Same for the Autopilot. Again, separate kit. Would you be interested in buying something like this? And if so, you know, would it be the panel only, or the component kit and the panel, or the full Monty? Again, bearing in mind, you know, the added value is you get the detailed step-by-step instruction manual, probably videos as well. Probably I'm going to do a written manual. That's the main manual, but I'll probably do some videos as well along the lines of my YouTube Twin Otter blogs. So they'll be included in the pack. So you shouldn't have any problem figuring out what to do. All the steps that you need to go through to set up the programming will be outlined, and so that's part of what you're paying for, really. Oh, how much is it going to cost? As soon as I name a figure, people are going to hold me to that, so I'm very reluctant to do that. I do have a figure in mind. I think all I'm going to say for now is it's going to be comparable to buying a Cytec multi-panel or the ProFlight radio panel. And I know that if you Google that, you're going to get a wide variation in what you pay for one of those, but you know, it's the sensible, realistic price for a Cytec panel. You know, that's roughly kind of what you're looking at to buy all the bits you need to build one of these from the kit. I'll be more specific when I've done the numbers, and I'm looking into the manufacturing at the moment. You know, and obviously it's very sensitive to that sort of cost. Okay, so yeah, let me know what you think.